So as usual, I have left the code for this question in the description. So if you just want the code, you can go there. But if you want the explanation for how the code works in the algorithm, then you can watch this video. So as for the question, it's easy. It's easy. Just that a little trick is involved in this thing, which will make it a little bit complicated, but it's still easy. So I'll explain to you how to do this thing. But first things first, the question. I think everyone read the question as usual, but I'll explain it in a brief way. What you're supposed to know. Basically, I'm going to explain to you not the question, but what you're supposed to actually be doing, because both of them are two different things. You can derive and remove the useless things from this question, and what you'll get is basically we'll be given a 2D matrix. I need to find out whether in this column, in all these columns, but in the corresponding column, does there include a sequence which is VIKA? Let's check here basically. So in this column, we need V first. So yes, V is there. The second column, there's nothing. So forget about the second column. The third column, yes, I is there. The first I. The third, fourth column, we have K. And the fifth column, we have A. So what they basically said is, for each and every column we go through each and every column. If there is the sequence of elements, the words are there, then we'll select it. If they're not there, or if they're not in the right order, we forget the column. At the end, we need to get Vika, which is the word we are looking for in this column. So if we get it, we should print yes. If not, then you should print no. So basically, this is easy actually. But the tricks that will be involved here is, for example, instead of A here, what if we take instead of A we take V again? So what will happen is, if we calculate V 2 times, then we'll get V or something like that. Those things are the tricks here. We have to basically make sure that once we take V, then we shouldn't take V again. We should just take I. Till we find I, we shouldn't stop it. So basically we need VIKA. How do we get that? Now look at this thing carefully. We need this in this sequence, the particular sequence. If we can get the sequence in this particular way, only then should we print yes. It's not that we have V here and I here and K here. We shouldn't print it like that. We should print VIKA. So it should go in a sequence. For each and every column, once we got V, we should check for the sequence, which means the next element is I. We should check for I. We shouldn't go back to V again. And similarly, once we got I, we should go back to K. Once we got K, we should go to A. And once we got A, we need to realize that we have all V, I, K and A. And then if this is in the order, which means that it shouldn't be that when we have A and we have all these things, it shouldn't be like K, V, I, A. These are all there, but these are in jumbled manner. We should get it in a particular manner, which is VIK. So for that, you might be thinking we can use a hash map and we can use an array or something like that. We don't need any of those things. All we need is one variable, which is previous. That's it. Just need one variable previous in order to check both the positioning of the sequence of the letters and whether the letters are present or not, which is Vika in this case. But this could be applied for anything, for any other things, but all that will make the code complicated. That's why they given us Vika. A particular letter, a particular word they gave us for this reason. So basically, what we'll do is we'll have a variable previous. Previous, what will help you is, initially previous will be empty. In this case here, if you look at it, it's empty. I'll just erase this thing. Now we don't need the array anymore because that's just iterating through it. We just need to iterate through the 2D array. That's an easy code we can write. We need the logic. So what is this thing? Initially, let's take that previous is 0. Not 0 exactly, empty. Empty string. So in this case, previous is empty. What we need to do is, the first condition we are supposed to write is, the first condition here we're supposed to check in this case is, when previous is empty, do in the 2D array, which is here, do we encounter a letter which is V? When previous is empty, do we encounter a letter which is V? Yes, if we encountered it here, in this case we encountered V, then yes, we satisfy the condition. We'll make previous as V. But this is previous. Now, With this one, we understood that yes, we have a previous value which is v. We have v as a previous value. Now, the second condition we're supposed to write, there are 4 conditions in this case. I'm explaining to you each condition. The first condition is if previous is empty and the value we encountered is v, then the condition is satisfied and you'll get previous will be equals to v here. The resultant will be previous will be v. Just write it like this. P empty and I is equals to v, and previous will be v. The second condition is if previous is equals to v and I is equals to k, then previous is equals to k. Now, for example, we encountered I. No, we encountered I. Sorry, this is not k, it's I. For example, we encountered I somewhere here. Yes. So when we encountered I, we should make sure that this condition is satisfied, which means that yeah, it is I, but the previous should be v. Then yes, previous will become I. This will no longer be previous. This will be previous from now on. Now the next one is similarly, if it's I and it's k, then previous will be k. So if we get k again, this will become previous. This will no longer be the previous. And if we get a at the end and k is the previous, then we get a as the previous. Now, then let's look at this. We reach the conclusion. Yes, we have a here now. Now, let's look at how this previous value will help us. So basically, we have previous equals to a. This determines that these 4 conditions, we went through each and every one of them. Because in order to get previous a, the condition which was written here was in order to get previous as a, we need previous as k and the element which is we encountered as a, right? So initially, when it was for a to be previous, this should have been previous and this should have been the I value. And for this to be previous, this should have been the I value and this should have been the previous. And for this to be previous, this should have been the I value again, this should be the previous. And for this to be the previous, this should have been the I value and this should have been the previous. If you look at it, we went through it from backwards. We went k, I, a, k, I, v. In the particular order too. We can't be like, not for this to be previous, this should be for this, for this, for this. So we need to go in this order for it to be satisfied. So for previous to be a, for previous to be at the end a, we need this sequence. And this sequence in the exact number of times, which means that we should be only be once. And I should be only be once. K should also be only be once. And A should also be once. So we have the frequency of each and every letter and the positioning in the correct order for previous to become A in this condition. So with that, it's basically simple. So with this, if we get previous as A, then we can just print it as yes, because if we get previous as A, the positioning is correct and the frequency of the words is also correct. Now another thing is, obviously, yes, it's a small thing, but I'll just write it down. If the carpet's length is 3, something like that. If the carpet's length is just like A, it's lowercase Latin letters. It's A, B, and C. That's it. This is the length. This is the carpet itself. Then since the length of this, the number of letters in the word is 4. So if it is less than 4, then obviously we can't get VK at all. Since even if it's like this, we'll get VIK. That's it. We can't get A anywhere. So obviously the first edge case you're supposed to write is if the length of the number of columns is less than the number of less than 4, then obviously it's no. If it's greater than 4, then this condition should be checked. So yeah, I guess I explained to you both the code and the intuition behind this thing. It's a simple one. You don't need to use hash maps and everything. That's all you need to check for this one. So yeah, as I told you, I wrote the code I given you the code description. I need to get good at my outros. As I told you, I have left my code in the description, the GitHub link. So if you want that, you can check it out, but I'll most likely I encourage you to try this on your own, because you need to try this on your own for you to understand it. I told you the explanation, how the intuition of the code, simple to code it down, because that's what's going to help you build your actual problem solving skills, and not problem solving skills. In this case, I solve the problem for you, but in general, what will help you is how to put your intuition into code. It's going to help you with that. But as usual, most of you are going to click it down, and probably most of you are already clicked down. So yeah, if you watch this video till this far, thank you for watching, and yeah, I'll see you again.